Hello, in this video we're going to go over a problem from Virginia Tech Regional Math Competition 2017. This problem is asking us to find the number of real solutions to a given equation. This is a really neat equation with lots of symmetry. So it's a square root, it has a 2, it has a squared on the left, and on the right it has cube root 3 and cubed. The very first thing that comes to my mind is that perhaps we would have to just take both sides, raise them to the power of 6, and then go from there. If you do that, if you raise the power of 6, on the left you are going to get 2 minus x squared cubed, and on the right you're going to get 3 minus x cubed squared. If you expand this one, you're going to get a huge mess. You're going to get an equation of degree 6, and solving that equation and understanding the equation involves some calculus, and even that would not be very simple. So you could take the difference of these two, take the derivative, find critical points and all that stuff. However, even finding the critical point would not be easy and may not even be possible, because you're going to have to you're going to be forced to solve equations that are not possible to solve. So next thing that you would that I thought was perhaps I can think about this as the intersection of two curves. One of them is y equals 2 minus x squared square root, and the other one is cube root of 3 minus x cubed. The first one is in fact pretty familiar. This is a circle, or rather a semicircle, because y is non-negative. The second one, there's also quite a bit of symmetry with that. The very first one, since it's a circle, it makes sense to parameterize that using cosine and sine. So perhaps we could use x equals root 2. Root 2 is the radius of that circle, cosine theta, and y equals root 2 sine theta. If you take that and plug it into the second equation, you get 2 root 2 sine cubed plus cosine cubed equals 3. At this point, you're going to get sine cubed plus cosine cubed equals 3 over 2 root 2. Now, at this point, you might be tempted to do different sum of cubes and go from there. You can try that. You're going to get a pretty big mess, but still, it's something that it might work. But I have one other relation between sine and cosine. I know sine squared plus cosine squared is equal to 1. And if you get the right side of this, this is more than 1. That seems a bit suspicious, because since sine and cosine are numbers less than 1, when you raise them to larger powers, it would have to become smaller. In other words, sine cubed plus cosine cubed would have to be less than sine squared plus cosine squared, or maybe equal, but not larger. But 3 over 2 root 2, which is square root of 9 over square root of 8, that's more than 1. So that seems like that shouldn't work, which means essentially this equation would not have a solution. Okay, so now let's think about how we can efficiently write down this solution. So really, I didn't use the fact that these are sine and cosine. I only used the fact that these are between 1 and -1. So perhaps what I can do is, instead of switching to sine and cosine, I could use the fact that x and y are between root 2 and negative root 2 and repeat the same argument. So let's now write down a solution that may even be like a simpler, faster solution. So first, let's write down the claim. We claim this equation has no solutions. So how do we write down the solution for this? So let's first assume that there is a solution. So on the contrary, suppose square root of 2 minus x squared is equal to cube root of 3 minus x cubed for some x. Now set both of them equal to y. Let y be square root of 2 minus x squared, which is also cube root of 3 minus x cubed. So we obtain the following system. Okay, so this gives us a symmetric system. X squared plus y squared equals 2, and x cubed plus y cubed equals 3. Now let's look at the first one. The first one tells us that x squared and y squared are both less than 2 or maybe equal to 2, which means absolute value of x and absolute value of y are both less than root 2. Okay, so that means if I take x cubed, that's less than or equal to square root of 2 times x squared. And if I look at y cubed, that's less than or equal to square root of 2 y squared. So that means if I add them up, x cubed plus y cubed would be, this is less than absolute value of x cubed plus absolute value of y cubed, which is less than or equal to square root of 2 x squared plus the square root of 2 y squared. But I know what that is. This is square root of 2 times x squared plus y squared. X squared plus y squared is 2, so this is 2 root 2. So what I showed was that x cubed plus y cubed does not exceed 2 root 2. But this is 3. X cubed plus y cubed is 3. So that means 3 is less than or equal to 2 root 2, which is a contradiction. So this contradiction means the initial equation does not have a solution. So if you would like to continue with these types of competition problems, feel free to subscribe to the channel, and I will see you in the next video.